There are two main groups of longevity-promoting supplements. One is the group that inhibit chronic diseases that kill us too early. Heart disease, dementia, etc. That's the group that we talked about in the first 3 videos of the top 5 supplements for longevity series. Then the second group is the group that works directly on the molecular and cellular pathways that cause us to age. Specifically, this group of supplements works on one or multiple of the 12 hallmarks of aging, attempting to block or slow down things such as mitochondrial dysfunction, DNA instability, or stem cell burnout. This group of supplements is known as geroprotective agents, and they could potentially add years to your life by modifying the fundamental pathways of aging, or by slowing down these root causes of aging. And today we're covering my top 5 geroprotective or lifespan extending supplements. We're talking about the science behind them, the impressive lifespan extension data in model organisms, and we're talking about exactly how you should take them, the dose, the form, the timing, and my unsponsored brain Rex. Let's jump in. Coming in at number 5 is taurine. And taurine is an amino acid that is produced by the body or ingested through animal products. However, taurine is not used to create protein. It stays its own separate molecule where it's used in a wide variety of processes within the body. For instance, it's used to create bile salts. It's used as an antioxidant to improve heart contractility or for neuromodulation, and the list goes on and on. But in regards to directly inhibiting aging and prolonging lifespan, taurine works by decreasing 5 of those hallmarks of aging. Specifically, taurine works to decrease cellular senescence, or essentially when the cells stop dividing and then release a bunch of inflammatory molecules that further drive aging. It also works to decrease telomere attrition, or essentially the shortening of the protective end caps of DNA that when they get too short, cells can no longer divide and replicate properly. 3, it also decreases genomic instability, or essentially the buildup of DNA damage over time. 4, taurine also decreases chronic inflammation, essentially when those immune cells and inflammatory molecules go unchecked and cause cellular damage. And 5, finally, taurine decreases mitochondrial dysfunction, and this is really the one that taurine shines in. Essentially, mitochondrial dysfunction just being when the powerhouses of the cell do not operate efficiently, and taurine works on multiple mechanisms to really improve mitochondrial efficiency. And due to its ability to decrease these 5 hallmarks of aging, taurine has been shown in multiple studies to prolong lifespan in model organisms. And it's important to note, though, that there are different levels of evidence when it comes to lifespan prolonging ability. The first and lowest level of evidence is in lower order organisms, or essentially model organisms that are not that similar to humans, such as yeast, fruit flies, roundworms, etc. And taurine definitely has evidence in this category, with studies noting that when roundworms were given taurine, those roundworms lived on average 10 to 23% longer than the roundworms that were not given taurine. And with higher doses of taurine, there were better effects in regards to promoting increased lifespan. Then the next level of evidence, higher up, is with higher order organisms, or model organisms that are a little bit more similar to humans. A lot of this research comes from genetically homogeneous mice, or essentially mice that are all genetically the same. And taurine has evidence in this category as well. When taurine supplementation was started in the middle age for genetically homogeneous mice, those mice were found to live on average 10 to 12% longer than the counterparts that did not receive taurine supplementation. And then maybe even more impressively, if the mice lived past 28 months in both groups, the ones that continued to receive taurine supplementation lived 18 to 25% longer compared to those that did not. And this goes to show that taurine supplementation might have even better lifespan promoting effects in older ages. And then the next even higher level of evidence comes from testing in higher order organisms, such as mice, but these higher order organisms are genetically heterogeneous, or they have different genetics. And this is considered a higher level of evidence because obviously all humans are genetically distinct. So testing in genetically distinct mice would be more comparable to testing it in humans. And there is a program that is really leading the way in this level of evidence. And that program is called the ITP, or the Interventions Testing Program. It's funded by the NIH, specifically the branch called the National Institute of Aging. And they run consistent experiments on genetically heterogeneous mice to test compounds to see if they positively impact the lifespan of these mice. They run the experiments in 3 separate labs in a very reliable, consistent way. So all of this to me makes an ITP study the highest level of non-human evidence we can have when it comes to lifespan extending ability. They've tested some compounds that have been found to prolong lifespan. They've also tested a lot that have not been found to prolong lifespan. To me, if they did a study and it showed that the compound, or the supplement in this case, did not prolong lifespan, that's enough negative evidence for me to not include it in this top 5 list. However, if they did a test on one of the supplements and found that it did positively prolong lifespan, then that supplement is going to be even higher up in this list. In the case of taurine, unfortunately, the ITP has not done a study on it yet, so we really don't have this level of evidence for taurine yet. That being said, I think there's enough positive evidence in the lower levels of evidence that you should still consider taking taurine as a lifespan promoting supplement. And I definitely think the ITP should do a study on taurine in the future. Interestingly though, in the studies we do have on taurine's lifespan extending abilities, the scientists note that one of the reasons it was able to have these lifespan promoting effects was that taurine's concentrations naturally decreased with age in their studies. Specifically, they noted that in mice, monkeys, and humans, the concentration of taurine decreased with age. And if this were the case, essentially if taurine's concentration actually reliably decreased with age, and we were able to supplement with taurine to essentially halt that process and essentially reverse aging, then taurine would be much higher up on my list. However, there's been some recent data that calls into question taurine actually decreasing with age. Specifically, there was a 2025 study that used longitudinal data and found that taurine concentration actually did not decrease with age. Essentially, longitudinal data means that they took individuals and measured it at time point A, maybe when they were 30, and then measured those same individuals' taurine concentrations when they were 50. And those concentrations did not decrease in the individual between those time points. However, the previous studies were more using cross-sectional data. Essentially, they looked at all 30-year-olds at one point in time and all 50-year-olds at one point in time, and the 50-year-olds had less taurine concentration than the 30-year-olds did. In longevity research and in lifespan promoting research, that longevity data is more highly valued. So for that reason, the fact that the longevity data did not prove that taurine concentration decreases with age, I do have some doubts on taurine being a reliable biomarker of aging. However, that being said, that does not rule it out in regards to it being a positive supplement for promoting lifespan. Think of it less as a replacement of a deficiency and more of a supraphysiologic supplementation to push taurine levels higher than what our bodies can actually produce. And this promotes positive lifespan gains due to further inhibition of all those hallmarks of aging. That mechanism to me is a little less important than the mechanism of replacing a deficiency, but it's still valid, and that's why we do still have all of this positive data on taurine promoting longer lifespan in all these model organisms. And it's why I still think it makes it into my top 5 list of lifespan extending supplements. However, it is worth noting here that for all the supplements we're about to talk about, we have no human evidence of prolonged lifespan, and that would be the highest level of evidence. It's really just very difficult to get this level of evidence in humans, obviously, because that study would be just insane to run. So to caveat the rest of our entire discussion here, I do think that all of these supplements show promise for human lifespan extension, but we really don't have any proof of that yet. That being said, what we do have for taurine is human studies that demonstrate improved health markers that could down the road lead to improved lifespan. For instance, we have a human study on taurine in 55 to 70-year-old women that demonstrated increased antioxidant ability, which obviously would lead to improved mitochondrial function and then hopefully work on that hallmark of aging. Similarly, we also have a meta-analysis on multiple taurine randomized controlled trials that demonstrate taurine's ability to decrease markers of chronic inflammation, SCRP, or decreasing MDA. Again, these obviously working on the chronic inflammation hallmark of aging. So all in all, we have good human data on health markers, and we also have great model organism data on prolonging lifespan. But how do we actually take taurine to get, hopefully, these lifespan promoting effects? For the form, you don't have to really overthink this one. Taurine is highly bioavailable in its standard free amino acid form, and this is what all the studies on taurine are on, so you can just get that standard taurine formulation here. For the dose, most human studies use anywhere between 1.5 and 6 grams of taurine per day. For lifespan extension properties, first let's look at the human equivalent dosing of the mice study that we have on its ability to promote lifespan extension. They used 1,000 mg per kg per day in these mice, and if you use the standard human equivalent dose formula, what you get is about 5.7 grams of taurine per day in humans for an average 70 kilogram adult. However, the human studies that use closer to 6 grams or 5.7 grams in the case of the human equivalent dose, those studies don't have as much safety data as the 3 grams of taurine per day studies. I think you're very safe at using 3 grams of taurine per day, and that 3 grams per day still has demonstrated antioxidant ability, just like that one study with the 55 to 70-year-old woman that we talked about. And you're still getting 10 times what you would get in dietary intake alone if you're just taking 3 grams per day. So in an attempt to get as much taurine as possible, given the whole dose-dependent response that we saw in some of the studies that we talked about, while still maintaining assured safety, I think 3 grams per day of taurine is your way to go. That being said, taurine is just a free amino acid, so it's likely to be safe up to that 5.7 grams. We just don't have long-term safety data to prove that yet. In regards to timing, there's definitely no set frequency or timing protocols for taurine. Some studies just do 1-a-day dosing, some studies do multiple times a day dosing. To me, when I look at taurine's pharmacokinetics, it makes more sense to do multiple times per day dosing. Reason being is that taurine is filtered out through the kidneys, and then some of it gets reabsorbed back into the bloodstream. However, those reabsorption pathways can get saturated. So if you spread out your taurine multiple times throughout the day, you have less chance of those reabsorption pathways getting saturated, and thus you can reabsorb more, and your taurine concentrations will be higher throughout the day with that multiple time per day dosing compared to just the once per day. Then outside of this, even in regards to timing, when in your life should you start taking taurine for lifespan extending effects? Well, let's go back to the lifespan extension study in mice. They started giving those mice taurine at 14 months of age, and that's equivalent to about 45 years old in humans. Reason being is they thought that taurine decreases with age, so let's give it back once the taurine starts decreasing, about at 40 years old. Even if we don't fully believe that taurine decreases with age, what we do know is that, at least by your 40s, the mitochondria are starting to become dysfunctional, and taurine helps with that mitochondria dysfunction. So to me, I do think it's a good idea to maybe start taurine supplementation for prolonging lifespan in your 40s, if you are going to take taurine for this purpose. And then in regards to brand, for my unsponsored recommendation, I really like Life Extension here. It's a great third-party tested brand, high quality, especially for the price, and they have 1 gram capsules that you can therefore take one of 3 times throughout the day. Coming in at number 4 is Spermidine. And Spermidine is a naturally occurring polyamine, essentially a small molecule with multiple amine groups that give it a positive charge. And this positive charge allows it to stabilize the negatively charged DNA and RNA, and also helps maintain some protein structure. Spermidine is naturally synthesized by the body, just like taurine, and then you can get additional spermidine through your diet. Specifically, foods that are high in spermidine are cereal grains, such as wheat, barley, also legumes, and then also soy derivatives. Spermidine's main actions in the body actually are to work on decreasing the process of aging. Specifically, spermidine works on decreasing 9 of the hallmarks of aging. 2 of those have a lot to do with the positive charge that it has. One of which is it works to decrease loss of proteostasis, essentially when cells can no longer keep proteins folded and organized correctly, which causes a buildup of protein waste, which further drives aging. Spermidine works to decrease that due to that positive charge it has. Spermidine also works to decrease genomic instability, partly again through that positive charge, and we already talked about this one with taurine. And then spermidine also works to decrease additional hallmarks of aging that taurine also worked on, that we already mentioned, being mitochondrial dysfunction, telomere attrition, cellular senescence, and chronic inflammation. And then spermidine works even further on aging by inhibiting additional hallmarks, one of which being dysbiosis, or when you have a buildup of detrimental bacteria or not enough good bacteria or just a lack of diversity of your bacteria in your gut as a whole. All of this creates additional inflammation and drives aging. And then spermidine also works to inhibit stem cell exhaustion, or when the body's regenerative cells can no longer grow and divide and repair tissue. But finally, the hallmark of aging that spermidine shines in and really decreases is disabled macroautophagy. Essentially, when the cell's system for recycling and cleanup gets dysregulated, and then there becomes, again, a buildup of waste product, which further drives aging. Spermidine specifically works on a molecular pathway known as the polyamine hypusonation axis, which increases autophagy or increases this cellular system of recycling and cleanup. And this really inhibits aging down the road at a molecular cellular level. Due to its ability to decrease all of these 9 hallmarks of aging, there have been multiple studies on spermidine's ability to prolong life in model organisms. First, in our lowest level of evidence in those lower order organisms, spermidine was found to increase the average lifespan of fruit flies by 30% when spermidine was given throughout the entire life of these fruit flies. And impressively, this effect was found to be dose dependent, with higher doses of spermidine giving higher lifespan promoting effects. And similarly, in yeast, spermidine administration was found to increase their average lifespan by 25%. And then in the next level of evidence, those genetically homogeneous mice, spermidine also has good data here. Specifically, when spermidine was given to mice throughout their entire life, it prolonged their average lifespan by 12%. And then when spermidine was only given at 18 months and older in these mice, which is an equivalent to about 55 to 60 years old in humans, when it was given then in the mice, it still prolonged their lifespan by 10%. But then, unfortunately, just like taurine, we don't have the next level of evidence. That genetically heterogeneous mice from the ITP studies, we don't have that spermidine study yet, but hopefully they'll do one soon. But right now, at least there's no negative data from the ITP on spermidine. And while there are obviously no human studies on lifespan extension, there are human studies on spermidine in regards to its ability to affect markers of aging. For instance, there was a small 2025 pilot study using spermidine in humans, which found that spermidine compared to baseline levels improved markers of autophagy, improved cholesterol panels, and decreased inflammatory markers. And then there was a different study looking at dietary spermidine intake and how different levels of dietary spermidine intake related to different levels of risk for all causes of death. Specifically, they found that every 1 standard deviation increase in spermidine intake was associated with a 24% lower risk of all causes of death. And this was after accounting for many confounding variables. And similar to taurine, there are some studies looking at spermidine concentration actually decreasing with age. Again, however, this is just cross-sectional data, meaning they look at 30-year-olds at one time point and 60-year-olds at the same time point, and the 60-year-olds happen to have less spermidine than did the 30-year-olds. Unfortunately, we don't have any longitudinal data proving the fact that spermidine decreases with age, so the jury's still out to me on whether it actually does decrease with age, but if it were found to reliably decrease with age, supplementing back with spermidine would be even more promising when it comes to lifespan extension. And if we are going to take spermidine for lifespan extending purposes, how exactly should we take it? Well, for the form, you basically have 2 main options. You can get synthetic spermidine, or most commonly, spermidine trihydrochloride, or you can get spermidine from plant extracts, such as wheat germ extract or rice germ extract. In the studies, they mostly use spermidine from plant extracts, with most studies using a wheat germ extract, but that study in humans that we talked about that showed increased markers of autophagy, they used a rice germ extract. Reason for this is it's hypothesized that the plant extracts contain other positive bioactives that can act synergistically with spermidine, and also they may help with absorption. However, there have never been a head-to-head study comparing synthetic versus plant extract spermidine, so it's impossible to say for sure which one is better. But to me, because of this mechanistic reason, as well as the fact that all the studies are really using plant extracts anyways, I'm going with a plant extract of spermidine for now, and I think you can't really go wrong with either a wheat or rice germ extract. When it comes to dose, that's pretty tricky because there's not actually a lot of human studies on spermidine. First, since we're talking about lifespan extension, let's look at the mouse study on lifespan extension and go from there. The human equivalent dose of the dose used in that study turns out to be about 170 milligrams per day for an average 70 kilogram adult. And unfortunately, the amount of pills or powder it would take to actually get to 170 milligrams of spermidine intake is just way too high. It's not practical. And even outside of this, we're really unsure if that high of spermidine intake in humans would even be safe. After all, the studies that have been done in humans are closer to 1 to 3 milligrams per day instead of 170 milligrams. And specifically, the pilot study that we mentioned that again improved autophagy markers, they used 2 different groups. They had a group that had 1.5 milligrams per day of spermidine and a group that had 3.3 milligrams per day of spermidine. They found that the 1.5 milligram per day group had no improvement in health markers. However, the 3.3 milligram group had all the positive effects that we mentioned. So based on this, also based on the dose-dependent response we saw in the fruit fly study, and based on the high human equivalent dose we saw in the mice lifespan extension study, I think it's warranted to say that higher doses are probably going to be a little bit better for lifespan extending effects when it comes to spermidine. However, how high can you go both safely and practically? Well, there have been studies using synthetic spermidine up to 40 milligrams per day for a month, and they did not show any adverse effects and were therefore deemed safe, at least for that month. And based on spermidine's mechanism and metabolism, it's likely going to be safe at doses up to this amount. However, long-term, years-long use of spermidine at this high of dose is really unstudied, so if you are going to be using it at that high of dose, regular lab work is definitely warranted. But since we did see those positive anti-aging markers at only 3.3 milligrams per day, I would say as long as you're doing 3.3 milligrams at least all the way up to maybe 40 milligrams per day, I think you are going to potentially get the lifespan promoting effects that spermidine could potentially offer. However, it is worth noting here that average spermidine intake through the diet is actually already 10 milligrams. So to me, moving closer to that 10 milligrams plus per day of spermidine through a supplement could actually be warranted. That being said, there is still something to be said for a standardized extract of a smaller dose, like we saw in the study, of only 3.3 milligrams. I still think you're going to likely get some benefit here as well. In regards to timing, all the human studies we have on spermidine just use 1 time per day dosing. And based on the bioavailability, pharmacokinetics, and just the overall mechanism of action, I do think that this is sufficient. You can just do 1 time per day dosing for spermidine. However, when in your life should you start to take spermidine for lifespan extension purposes? Well, based on the fact that when they gave the mice spermidine throughout their entire life, they only got 2% longer life compared to giving it only after 55 to 60 years old in human years, I think that marginal of an increase is not worth taking it throughout your entire life. So personally, I think starting to take it at around your 50s or 40s makes a little bit more sense. I think mechanistically, this also makes a little bit more sense just because your autophagy pathways are going to decrease in middle age. So to help out those autophagy pathways, I think it's going to benefit you to start taking it in your 50s or maybe 40s if you really want to make sure you're getting max effect. But I don't think you need to start taking this one in your 20s or 30s. And then finally, for an unsponsored brand rec, I was searching for one that had a plant-based extract, one that would allow us to get 3 to 40 milligrams practically and cost efficaciously, and one that was created in GMP certified facilities that had good third-party testing. And with all this, I selected OMRE. They have a great 5 milligram wheat germ based spermidine extract and at a reasonable price. And again, because we have the study that with only 3.3 milligrams, you did have some positive effect. I think you could really get away with only taking one of these per day, but based on the dose-dependent effects of it, the high human equivalent dose, and high already average dietary spermidine intake, personally, I would go with taking 2 capsules or 10 milligrams of spermidine from this wheat germ extract per day. Coming in at number 3 is green tea extract. And green tea extract is essentially a concentrated source of green tea polyphenols, or essentially those plant-based anti-inflammatories and antioxidants. And specifically, green tea, or green tea extract in this case, are very high in the polyphenol group known as catechins. And catechins are unique in their high bioavailability, their extremely great antioxidant ability, and their positive effect on metabolism. And there are multiple catechins that make up green tea extract, and probably the most important of which is EGCG, or epigallocatechin gallate, and that is the strongest antioxidant of the group of catechins. And due to these antioxidant and anti-inflammatory effects of all these catechins, and specifically EGCG, green tea extract has been found to have some pretty impressive anti-cancer properties, and it's also been found to have some pretty positive effects on cardiovascular disease prevention. And then specifically in regards to inhibiting aging, green tea extract and the catechins that make it up work by decreasing 9 of the hallmarks of aging, multiple of which we've already talked about, including decreasing mitochondrial dysfunction, chronic inflammation, loss of proteostasis, genomic instability, cellular senescence, and dysbiosis. Then the hallmarks of aging that green tea extract also decreases that we haven't mentioned yet are decreasing epigenetic alteration, or when the process for turning on or off genes becomes dysregulated. Green tea extract also decreases altered intracellular communication, or essentially when cell-to-cell signaling through hormones, growth factors, or other molecules goes awry. And finally, green tea extract also decreases dysregulated nutrient sensing, or essentially when growth and storage pathways such as IGF-1 or mTOR run unchecked, and then cleanup pathways such as AMPK or sirtuins are decreased. But out of all of these, green tea extract works the most to decrease mitochondrial dysfunction. Specifically, the catechins in green tea extract work to initially very mildly inhibit some mitochondrial processes. This then essentially triggers a positive adaptive response to, in the future, further bolster mitochondrial activity. Essentially, it's basically like training your mitochondria to be more efficient down the road at energy production. And through this mitochondrial training and through its action on the other 8 hallmarks of aging that it works on, there have been some pretty impressive preclinical studies on green tea extract prolonging life. Specifically, in our first level of evidence, those lower order organisms, different green tea extracts of different concentrations of different catechins were shown to increase the average lifespan of roundworms by 10 to 32%. Then in our next level of evidence, those genetically homogeneous mice, green tea extract was found to increase their average lifespan by 6.4%. And then finally, with our highest level of non-human evidence, those genetically heterogeneous mice from ITP studies, we actually do have some evidence on green tea extract here. And this is why it gets this high spot up in the list. Initially, when they ran their study and ran their statistical analysis, the ITP found no statistically significant increase in lifespan when green tea extract was used. However, when they used an updated statistical analysis, they did find a 7% increase in average lifespan in female mice when green tea extract was given. And this statistic right here demonstrates another benefit of the ITP studies, and that is that they separate out male and female mice when they're doing their statistical analysis, which is important because these two are not always equivalent in how supplements or other medications affect their lifespans. In this case, only females were affected statistically compared to males were not. And the opposite will be true for further supplements that we're going to talk about in this video. And then outside of all of this lifespan extending data in model organisms, we also have some pretty interesting green tea data in humans as well. For instance, we have one large 300,000 person population-based cohort study, which demonstrated that people who drank 5 or more cups of green tea per day, compared to those who had less than 1 cup per day, had 10% lower risk of all causes of death in men and 18% lower risk of all causes of death in women. There are also multiple human studies, including randomized controlled trials, which demonstrate that higher intakes of green tea are associated with improved markers of biological age. And then there are other human studies on green tea extract decreasing markers of oxidative stress and inflammation as well. So due to all of this consistent positive data in humans, as well as the positive data for lifespan extension in model organisms at every level of evidence, green tea extract makes it at number 3 on this list. But if you do want to take it for lifespan extension, how exactly should you take it? In regards to form, the main thing to consider when it comes to green tea extract is the different amounts of catechins in the extract. As we mentioned previously, there are multiple different catechins or the specific type of polyphenol in green tea extract, but the most studied and probably the most important is EGCG. And EGCG is the most studied for lifespan extension itself, and specifically that roundworm study that we mentioned earlier actually only used EGCG instead of using a green tea extract with other catechins in it. However, the mice lifespan extension studies, both the one from the ITP and the genetically homogeneous mice, both used green tea extracts with all different types of catechins, not just EGCG. Unfortunately, they didn't tell us exactly how much of each catechin was used in their extract. However, we can assume based on what is most commonly used in the studies and what a standard extract of green tea extract is, that about 50% of it is EGCG, and then the rest of it is other catechins. So, should you use a mix like the mice studies did, or should you use EGCG alone? Well, I think you should go with a mixture like the mice studies did, and here's why. EGCG is the most powerful at prolonging life. However, it's also the most powerful at potentially causing liver toxicity. And because of this, multiple studies note that it'd be advisable to take 300 milligrams of EGCG per day or less to ensure that you're not going to get any liver toxicity. So by taking a mixture of catechins, you can stay below this threshold for EGCG while still getting benefit from other catechins as well. i.e., I'd rather take 600 milligrams of total catechins with 300 milligrams being EGCG than taking just 300 milligrams of EGCG alone. And on top of this reasoning, using the standard mixture of 50% EGCG is also what most of the human studies do anyways. A lot of them use a standard formulation called Polyphenol E, which is about 50% EGCG. And then outside of just looking at the amount of different catechins in the extract, Another important consideration is, should you use an advanced formulation of green tea extract that improves its bioavailability and absorption? Green tea extract is pretty difficult to absorb properly, and it has a decently low bioavailability in humans. So there have been formulations such as nanocarrier formulations or liposomal formulations, or formulating it with other bioactives that improve bioavailability, all in the name of hopefully improving green tea extracts and its catechins bioavailability. However, all of the human studies on green tea extract have used just standard formulations and have demonstrated great effect, so I wouldn't pay too much more for one of these advanced formulations personally. And then the last thing to mention when it comes to the form is, if you're not really wanting to add another supplement, but you still want to get some benefit here, maybe consider switching coffee to green tea, for instance. This isn't how the lifespan extending studies do it, which is why we're talking about the supplement here, but we did talk about those studies that 3 to 5 cups of green tea per day did result in some pretty great health outcomes. So just making a switch to drinking more green tea could also be beneficial here as well. But if you are going to stick with the supplement, how much of it should you take each day? Well, again, starting with the human equivalent dose for the mice lifespan extension study, specifically using that ITP data, the human equivalent dose we get from that is about 1,700 milligrams per day for a 70 kilogram adult. Assuming a 50% EGCG extract, that means the human equivalent dose here would have been about 850 milligrams of EGCG per day, which, as we talked about already, is well above our 300 milligram per day threshold to ensure safety. And I will say that 300 milligrams per day is a very conservative threshold. Most of the studies up to 600 or even 800 milligrams per day didn't demonstrate liver toxicity, but that 300 milligram per day mark was set to really ensure that over the long term, you're not developing any liver toxicity. And I really like staying below that threshold for the long term if you're taking this for lifespan extension, just to ensure that you're not going to cause any damage when you're trying to, again, promote health and promote lifespan extension. That being said, if you do want to go higher, closer to 600 or 800 milligrams of EGCG per day, then I would definitely recommend getting your liver enzymes checked pretty regularly. But so to me, on the final recommendation for the dose, I'm trying to get as close to that human equivalent dose as possible while maintaining practicality and maintaining safety. So what I'm doing is doing a 50% EGCG extract and doing about 500 to 600 milligrams total of that extract, meaning you're getting near that threshold, the 300 milligrams of EGCG per day, and still getting additional benefit from the other catechins in your extract as well. And it's worth noting that this is a common dosing strategy used in human green tea extract studies as well. In regards to timing, due to the low bioavailability and the short half-life of green tea extract, it is recommended to spread this out multiple times throughout the day to increase catechin exposure over the long term. So depending on the amount of EGCG and the amount of catechins in each one of your tablets or capsules, I'd recommend taking this one at least 2 to 3 times per day. And it's worth noting here that you really want to take this without food. Studies have shown that taking it without food increases the bioavailability by 2.7 to 3.9 times, which is pretty significant. And then finally, in regards to timing, when in your life should you start taking it? Well, compared to Spermidine, I think you can actually start taking green tea extract a little bit earlier if you're wanting to maximize its effect on your lifespan. Its antioxidant effects and really its ability to train the mitochondria could provide benefit even much earlier in life. And this was also what was done in the ITP study, where they actually started giving green tea extract to the mice at only 4 months old of age, which is equivalent to being in your 20s in human years. So I think you could consider starting to take green tea extract even then if you're taking it for lifespan extension purposes. And I would definitely consider taking it if you're a female, as that is the group that was found to have the best lifespan extending effects in that ITP study. And then finally, in regards to unsponsored brand recs, I really like Nootropics Depot here. Great third-party tested brand at a great cost. They have a similar to a polyphenol E type extract with 45% EGCG, and they have 500 milligram tablets. So what I'd recommend is actually halving those tablets and taking them 2 times per day if you want to stay below that assured safety threshold that we talked about earlier. Or if you wanted to increase your dose slightly or take it 3 times per day, Nootropics Depot also has a great powder you could use. And then if you're only going to take it 1 time per day, then Life Extension is another good option here. Quality brand again with a good budget option, but the max dose is really just in 1 capsule, so you'd only be able to take it 1 time per day. Coming in at number 2 is Astaxanthin. And we've actually already covered Astaxanthin on the channel before, so if you want to hear more about its specific disease prevention abilities, check out this video here. But we'll cover it a little bit more here as it pertains to lifespan extension. Astaxanthin is a carotenoid, or basically just a pigment, that is produced mostly from microalgae, and it has this characteristic reddish-orange hue. Humans don't produce this one endogenously, so you'd have to get it from your diet or through supplementation. But if you're going to get it from your diet, you're getting it from seafood that eats this microalgae, such as wild-caught salmon, lobster, shrimp, etc. And astaxanthin's main mechanism is its insane antioxidant ability. Specifically, studies note that it has 6,000 times more antioxidant potential than does vitamin C. And then in regards to directly working on anti-aging and promoting lifespan, astaxanthin works on 6 of those hallmarks of aging. Specifically, it works to decrease ones that we've actually already talked about with some other supplements. 1, it decreases loss of proteostasis. 2, it decreases dysregulated nutrient sensing. 3, decreasing cellular senescence. 4, decreasing genomic instability. 5, decreasing altered intercellular communication. And finally, 6, the one that it works to decrease the most is, like some of the other supplements, mitochondrial dysfunction. And specifically, as we already mentioned, this is due to astaxanthin's insane antioxidant potential. Essentially, it reduces oxidative stress to the mitochondria, allows them to function more efficiently for longer, and that is how you inhibit aging if you're astaxanthin. Based on these mechanisms, we have great preclinical data on astaxanthin promoting lifespan extension. In that first level of evidence, those lower order organisms, for instance, astaxanthin was shown to increase the average lifespan of roundworms by 16 to 30% in a dose-dependent manner. And then similarly, there's additional studies demonstrating astaxanthin increasing lifespan in fruit flies, and also studies demonstrating that astaxanthin increased the lifespan of yeast as well. And then for the next level of evidence, those genetically homogeneous mice, astaxanthin is actually lacking there. There's really only studies showing that astaxanthin improves this type of mouse's health markers, such as improving its heart function or improving its inflammatory markers. But there's really no studies on genetically homogeneous mice in regards to astaxanthin promoting their lifespan. But where astaxanthin really shines is its data in the ITP studies. That highest level of preclinical evidence where we're looking at those genetically heterogeneous mice, astaxanthin was shown to increase the average lifespan of the male mouse in this group by 12%, which is very, very incredible for an ITP study. And then there are also many human studies demonstrating astaxanthin's positive health outcomes. Ones that we've already talked about in our prior video on astaxanthin, but multiple studies on cardiovascular disease, brain health, skin and eye health, and etc. The list goes on. So check out that video for more on those studies. And then there are additional human studies on astaxanthin decreasing markers of oxidative stress or inflammation. So with all of this positive human data, along with especially that ITP study, I think astaxanthin has a lot of promise for lifespan extension. But how exactly should you take it for that purpose? In regards to the form, it's pretty important to get this one right because astaxanthin is incredibly fat soluble, which makes it pretty difficult to absorb. The first thing to make sure of, though, is that you are getting your astaxanthin from Haematococcus pluvialis microalgae, essentially the natural form of astaxanthin, because getting it from the synthetic form means you're getting more of the less active isomer. So getting the natural form is pretty important here. From there, it's a matter of selecting a form that will actually allow that correct isomer from the natural astaxanthin to be actually absorbed, because again, that fat solubility makes it difficult to absorb. So the most studied form here is Astaril. It uses oil-based technology to help with absorption, and it's probably the most studied form of astaxanthin. So that's the one that I'm going with. However, there are other formulations using other fat-based technologies to improve absorption, one of which being BioPure from AX3. It's getting more and more studies these days, and it's touted to have even better bioavailability than Astaril. Granted, this is from unpublished studies, so really hard to say. But I think you can't go wrong with either of these forms or any other form that is demonstrated to have a higher bioavailability due to some fat emulsion technology. For the dose for lifespan extension, again, I like to start with the human equivalent dose from that ITP study. And when you calculate that out, you get a dose of about 1568 milligrams per day for a average 70 kilogram adult, which is just astronomically high and not practical for human use. So it's unclear if lower human doses are actually going to result in lifespan extension like it did in the mice ITP study. However, I still think there is some hope for it just because we have seen positive health marker outcomes from lower human doses of astaxanthin. So I still think astaxanthin shows promise for lifespan extension. But what dose should we take for that purpose? Again, It's a similar discussion. Because of those dose-dependent effects we've seen in the other studies, and because of the high human equivalent dose, it's really a question of how high of dose can we take practically and safely to hopefully maximize our lifespan extension effects. Well, there have been some shorter term, about 16-week studies using 24 milligrams of astaxanthin per day, and there were no adverse effects, no safety concerns. However, most of the human studies are at 12 milligrams per day or lower, and we do have more safety data here. So I would say stick with either 12 milligrams a day or up to 24 milligrams a day. If you are using that 24 milligrams per day, I would recommend, again, getting regular lab work. In regards to timing, most human studies use astaxanthin 1 time per day. However, other studies do note that smaller doses may be absorbed better. And there are human studies using 6 milligrams twice per day. So to me, I think that spreading it out multiple times per day is likely ideal to get the most bioavailability out of your astaxanthin. So I would split this one up at least 2 times per day, and maybe even more if you're taking higher than 12 milligrams. One thing that is for sure though, is that you need to be taking your astaxanthin with meals, and specifically with fat-containing meals, as this will definitely improve your bioavailability, again, due to it being fat-soluble. And then again, with timing, when in your life should you start taking it? Well, for that mouse ITP study, they started giving it to the mice at 12 months of age, which is equivalent to your late 30s or early 40s. And I think this is a reasonable time to start it. You know, it's similar to taurine, trying to improve mitochondrial dysfunction, which decreases around this time. So I think starting it in your late 30s, early 40s is a good idea. But if you wanted to start this one earlier, like green tea extract, it's also not necessarily a bad idea either. And this is also one, though, that I would prioritize if you are male, as this is where the ITP positive data was seen. And finally, in regards to unsponsored brand recs, if you want the tried and true Astaril, and that's where I'm going with right now, I would go with Nature's Lab. They have 6 milligram oil-based capsules that you can take 2 to 4 of per day, depending on your dose, and then you can easily split it up multiple times throughout the day. But if you want the more up-and-coming BioPure, then you're going with AX3 here. Also a great company, just not as much studies, and that's why I'm going with Astaril and Nature's Lab right now. Coming in at number 1 is glycine, and glycine is another amino acid, just like taurine. However, glycine is proteogenic, meaning it is actually incorporated into proteins. Glycine is a non-essential amino acid, meaning that your body produces it. However, you can also get additional glycine in your diet through collagen-dense animal products, and to a lesser extent in beans, seeds, and nuts. And then these dietary sources, or supplemental sources, as we're talking about here, can be very important in certain conditions. And this is why glycine is considered a conditionally essential amino acid. And then outside of just being incorporated into proteins, like we mentioned, glycine can be used as its own separate molecule as well, where it has multiple functions throughout the body, now similar to taurine. For instance, glycine works on its own to lower chronic inflammation, along with lowering metabolic syndrome markers. And it even works to improve sleep quantity and quality, as we talked about in our video on top supplements for sleep, and you can watch that one here. But when it comes to directly working to decrease aging and prolong lifespan, glycine works on 5 of those hallmarks of aging. To a lesser extent, it decreases genomic instability, disabled macroautophagy, and 3, chronic inflammation. And then perhaps more importantly, glycine decreases mitochondrial dysfunction, and this is probably glycine's second most important action when it comes to lifespan extension. And then its most important action is decreasing dysregulated nutrient sensing. Specifically, what glycine is doing is decreasing methionine levels. And it does this by upregulating glycine and methyltransferase, or GNMT, which metabolizes out methionine. So essentially, by giving back additional glycine, what you're doing is mimicking methionine restriction, because you're lowering methionine levels. And methionine restriction is a very well-studied intervention for prolonging life. And this is because high and built-up levels of methionine contribute to multiple of those hallmarks of aging. So by restricting it or lowering it through glycine supplementation, we can prolong life and decrease aging. Based on all of these mechanisms, glycine has lifespan extension data at every level of preclinical evidence. The first level, those lower order organisms, glycine was found to increase the average lifespan of roundworms by up to 33%, and this was when glycine wasn't even given until adulthood. And then in fruit flies, by directly overexpressing GNMT, again, basically the main mechanism of glycine, Fruit flies were found to live 15 to 25% longer on average. And then in the next highest level of evidence, those genetically homogeneous mice, glycine was also found to promote lifespan extension here. We have a study of glycine being combined with N-acetylcysteine, or NAC. And when the mice were given this combination of glycine plus NAC, they were found to live 24% longer on average. The reason to combine them is because glycine, again, works on mitochondrial dysfunction by promoting glutathione synthesis. And glutathione is your body's master antioxidant. So by giving more antioxidant capacity, you decrease the oxidative stress to the mitochondria and decrease mitochondrial dysfunction and therefore decrease aging. Well, N-acetylcysteine, or NAC, also helps with glutathione synthesis. So now you have glycine plus NAC both contributing to more glutathione equals more antioxidant capacity equals less mitochondrial dysfunction and decreased aging. So that's what we saw in this genetically homogeneous mice study. And then the highest level of non-human evidence is again the ITP studies, the genetically heterogeneous mice, and this is why glycine really grabs the top spot here, because glycine supplementation alone increased the average lifespan in both male and female mice. In female mice, it increased the average lifespan by 4%, and in male mice, glycine increased the average lifespan by 6%. And excitingly, the ITP has a study on glycine plus NAC coming in the pipeline. So we'll be excited to give you the results of that when we see it. And as with all other supplements on the list, again, obviously there's no human data on lifespan extension, but there are good human studies on glycine promoting other health markers, such as decreasing chronic inflammation, for instance. And that glycine-NAC combination even has human studies demonstrating the same improvement in health markers that the mouse studies did. For instance, it demonstrated improved markers of glutathione production and decreased markers of oxidative stress. And outside all of this, just as with taurine and spermidine, there are cross-sectional studies that demonstrate that glycine concentrations may decrease with age. Similar to spermidine, we have no longitudinal data on this yet, but if glycine was found to decrease with age, again, that would just further bolster its promise to me as a lifespan extender. So if you are going to add glycine or glycine plus NAC, how should you actually take them for the best chance at lifespan extension? In regards to form, similar to our discussion on taurine, glycine is just an amino acid. So its standard free amino acid form is going to be highly bioavailable, and this is definitely sufficient in regards to a form for glycine. And also similarly, N-acetylcysteine is just a derivative of the amino acid cysteine. So also its standard form is also going to be highly bioavailable and also sufficient. And all human studies using NAC or glycine are using these forms. For dosing, the first thing to mention for glycine is that the average dietary intake of glycine is 3 grams per day. But how much additional should we take through supplementation to best get the chance of lifespan extension? Well, as always, let's start with the human equivalent dose of the most impressive data we have, the ITP study in this case. They used a diet that was 8% glycine. So this is going to be very, very high. And the human equivalent dose, when you calculate that out, is about 75 grams of glycine per day for an average 70 kilogram adult. So unfortunately, this is similar to a couple of the other ones on this list. The human equivalent dose of this study is just way too high to be practically taken as a supplement and way too high to likely be taken safely as a supplement in humans. After all, studies note that the upper limit of safety for glycine supplementation is closer to 129 mg per kg per day, which for an average 70 kilogram adult is closer to about 9 grams per day. Now, given that glycine is just an amino acid, it's likely that doses higher than 9 grams per day will be safe. However, they're just not proven in long-term studies yet, and very, very high doses could be neurotoxic. So what dose should we take given that super high human equivalent dose, but we're kind of capped at 9 grams to ensure safety? Well, fortunately, the human GlyNAC studies, the glycine plus NAC studies, used much more reasonable doses and still got beneficial health marker benefits, such as improving glutathione again and decreasing oxidative stress. That study used doses of 100 mg per kg per day of both glycine and NAC. So for an average 70 kilogram adult, that is 7 grams of NAC per day and 7 grams of glycine per day. So I would stick with more of this dose. Keeps you below the safety threshold and you're also likely still getting benefit. So for glycine, depending on your diet and size, I would take 6 to 7 grams per day. But for NAC, how much should we take? Should we just take those 7 grams just like glycine from the glycine NAC trial? Well, here we don't have as much long-term data proving the safety of 7 grams of NAC per day. Again, similarly to glycine, NAC is just a derivative of an amino acid. It's likely safe at that 7 grams per day, and it was safe in that GlyNAC study. However, we don't have the long-term data on it, but we do have more long-term safety data on up to 3 grams of NAC per day. So right now, if you're looking to really ensure your safety but get the most out of your lifespan extension potential, I would be taking, again, 6 to 7 grams of glycine per day and 3 grams of NAC per day if you're going to add that in. But again, likely up to 7 grams of NAC per day is likely safe. In regards to timing, glycine has a very short half-life and is very rapidly cleared out of the plasma. So it would make sense to split your dosing up multiple times throughout the day to ensure more consistent plasma levels. In the human glycine plus NAC study, they split it up to 2 times throughout the day. And then in other high-dose glycine studies in humans, they split it up to 3 times per day. So if you're taking 7 grams of glycine per day and 3 grams of NAC, or even 7 grams of NAC per day, I would recommend at least splitting it up 2 times per day, but ideally I would split this up 3 times per day to improve tolerability, aka decrease stomach upset that you could get from taking the supplements, but also to increase efficacy by improving plasma concentrations again throughout the day. And then again, what age should you start taking these supplements? Well, in the ITP study of glycine alone, they started giving the mice glycine at 9 months old, which is equivalent to about 30 years old in humans. But in human GlyNAC studies, the glycine plus NAC was found to only have benefit in older adults. For instance, in one of the GlyNAC studies, they gave glycine plus NAC to the older adults, which on average were 70 years old, and they found that they were able to improve their glutathione status and improve their oxidative stress status. However, when they gave the same supplements to younger adults with an average age of 25 years old, they were not able to see any effect. This is likely due to the fact that when you're older, aka when you're 70 in this study, you have less glutathione already. You have more oxidative stress going on. So that's when the glycine plus NAC is actually going to help you because you're getting more glutathione from it. So based on these studies and the mechanisms that we know of, I would say that you could start taking glycine 30s to 40s and see some potential lifespan extension effect. Reason being is, again, that methionine restriction probably being beneficial even in younger years. However, if you're going to add in NAC, I would wait to do that until you're 50 to 70s because that's when you're likely going to have more depleted glutathione status, more depleted antioxidant ability, and that's when the glycine plus NAC combo is really going to work in your favor. And finally, in regards to an unsponsored brand rec, for glycine here, I really like Life Extension as far as a great budget option that is also third-party tested and a quality supplement. They have great 1 gram capsules, so you can just take 6 to 7 of those spread out 3 times throughout the day. And if you are going to add NAC in here, I would also recommend Life Extension. They have 600 milligram capsules, again, so you could take 5 of those if you're going for that 3 gram goal and split that up 3 times throughout the day. So those are the top 5 for lifespan extension. And if you want more top 5s for longevity, check out this playlist here.